Good afternoon. Assalamualaikum. Last class we had done on the LU decomposition. Okay, do you have any question before I proceed to the next topic? We start at this exercise last class on Monday. Any question for the LU? Clear? Okay, so today I proceed to Jacobi, Gauss Seidel and Jacobi, where this is an iteration method. Okay, last time Gauss elimination and Gauss elimination and LU, it is matrix. Okay, LU decomposition. It is matrix form in order for us to find the unknowns. Okay, but now we use iteration method, where the method that we will cover is Gauss Seidel and Jacobi. Okay, Gauss Seidel and Jacobi. Okay, Gauss Seidel here is iteration. Gauss elimination and Gauss Jordan is matrix. Okay, this is Gauss Jordan, where the Gauss Jordan diagonal is 1. The rest are zeros. Okay, so Gauss Seidel is iteration method. Okay, don't make mistake on that. I'll go through the slide as in your lecture slide first. Okay, I'll explain the concept, then we will do the exercise for you to understand further. Now let's consider one example from chemical engineering problem. This one we had discussed earlier on the material balance analysis, where we have a process, okay, this process with few unknowns. Why am I cannot go down? Okay, we have these 5 reactors, and you are being informed what are the inlets, the outlets, what are the components. And these, there are few unknowns. Okay, we want to know what are the composition of C1 over here, C2, C3, C4, and C5. So from here, we need to generate or develop the equation. Okay. Okay, this one's from the previous explanation when I introduced you the numerical method. Okay, where you need to solve it by doing material balance analysis, mass flow in, mass flow out. Okay, the inlet, this is the inlet equals to outlet. So we will have unknowns over here, which involve C3. Okay, we focus on reactor 1. Inlet is from here, Q1, C1. And Q31, okay, from reactor 3. Outlet from reactor 3 enters reactor 1. So it brings together the feed. So we need to know what is C3 over here. Okay, this is the inlet. Then the outlet, it involves the Q15 over here, the outlet stream, and Q12, which this stream 15 enter the C5. Okay, so that's why you have here the outlet Q15 multiplied by C1, because it brings together the composition from reactor 1. Okay, Q12 multiplied by C1 as well. Outlet stream, the feed Q12 over here, and it brings together the composition from reactor 1. Okay, so from there, you will get your unknown, which is C1 and C3. and generate the equation. Okay, this one is for rectangle 1 only. So you need to develop the equations for all the reactors over here in order to find out what are the unknowns. Okay, so this is the final equation developed from the reactors. So you have 5 unknowns over here. Okay, so we can use iterative scheme or the matrix scheme last time. So if you have here 5 unknowns, if you use matrix, what dimension of matrix that you need to use? 5 by 5. 5 unknowns, so 5 by 5. Okay. Another method is using iteration. Okay, usually in computer software, we will do the iterative methods. Now we have here the 3 sets of equation. For example, x1, x2, and x3. So each equation belongs to one unknown. Okay, let's say this is equation 1, 2, and 3. x1, your unknown x1, x2, x3. So if in matrix form, from the previous class, you arrange it into matrix form as like this. A, X equals to B. Okay. Now, for iterative, we need to rearrange for the unknown equation. Equation 1 refers to x1. Equation 1 refers to x1 only. So you need to rearrange to get x1. Equation 2 only focus on x2. Equation 3, x3. Okay, if you have 5 unknown just now, you should have 5 equations. Okay. Now, for the iteration, it always starts from 0. To calculate the new value for x1, x2, and x3. Okay, I explain first. Later, we'll do exercise. Always start from 0. Remember that. Now, this one, the error, we can check whether it is converging or diverging. How to know if it is converging from the error? Decreasing. Okay, the error should be decreasing. If the error give you random numbers, then it is divergence. Okay. Okay, in Gauss, Seidel, and Jacobi, it depends to the diagonal dominant. In order for the iteration to be convergence, in convergence. Okay, diagonal dominance means here, the diagonal dominance. We check on the diagonal values. Okay, what does it mean by diagonal dominant is when you have, let's say, these 2 equations. Okay, you have these 2 equations. Diagonal, so we go diagonally, check whether it fulfills this requirement. Okay, this one is A11, okay, here. A11 must be larger than A12 plus A13. So here is A11. Here is what? A12. Here, A21. Here is A22. Okay, so A11, this one, we follow this one. A11, which is 3, should be larger than A12. What is A12? Minus 1. Plus A13. Is there any A13? No, right? This one only 2 by 2. So there's no A13. So, meaning that A11 must be larger than A12. This is the rules. Must be larger. But eventually here, is it larger than A12? Larger, right? Okay, so it meets the rules. Then check for the A22 whether 5 larger than A21, which is 2 plus A23. There's no 2, 3 over here, so 5 is larger than 2, so it meets the rule. Then you can proceed your iteration using this arrangement. Okay, so from here, these two equations, equation 1 goes to -4. So from equation 1, you must generate x1. So from here, x1 is plus x2 over 3. Then from the second equation, this is first equation. Second equation, which is 2x1 plus 5x2 equals to 2. So from here, you generate x2. Over 5. Okay, so these are the equation of the x's that you will be using in your iteration. Okay. Okay, I repeat for B, equations for B. Now, step 1 to check the diagonal dominance. Step 1, check the diagonal dominance. Okay, in diagonal dominance, other than you are using this A11, A22, actually, I used to teach my student to use easier letter where A, B, use A, B, C, D. Okay, it's up to you how you want to use. F, G, H, I. Okay, so A must be larger than B plus C. Similar to this, okay, but I use other letters. Diagonal, so we go diagonally. So A, then E. E larger than D plus F. I larger than G plus H. Okay, first equation we check the diagonal dominance rules. Remember, the values over here is in modulus. So regardless of the negative signs. Okay, modulus. So A, the first equation, A, which is 4, B plus C should be larger than B plus C. So B, which is 2 plus 1 equals to, equals to 3. Now 4 larger than 3. This is correct. It meets the rule. E, okay, E here in the second equation, there is no E, 0. X2 is 0. So E is 0. D plus F. D is 1 plus 2. Of course, it is smaller than 3. Smaller, so it doesn't meet the diagonal's dominance rule. Okay. Third one, we go to third one, which is I, 1, G plus H. G is 3 plus 5. So 1 is smaller than 8. It doesn't meet the rules as well. So what to do when the diagonal dominance doesn't follow? You must rearrange the equation so that it follows the diagonal dominant. Since equation 1 follows, so remain. We just rearrange the equation 2 and equation 3. Move equation 3 to above position, 2 comes down. Okay, so once you rearrange, so the new equation, rearrange the equation, rearrangement. Now, for this one is equation 1, which has follows the rules. Three move to 2. So 3 x1, no x2, okay, plus 0 x2, then, sorry, 5 x2, sorry. Okay, plus minus. Minus 5x2 plus x3. Then equation 2 move down. x1, 0x2 plus 2x3 equals negative 4. Okay, now you check back the diagonal dominance rule. Does it follow? Okay, here 4 should be larger than 2 plus 1. This one right already just now. E, which is 5, should be larger than 3 plus 1. It makes 5 larger than 4. Then third equation over here, the one that we rearrange, 2 larger than 1. So all now fulfill the diagonal dominance rule. After you fulfill the diagonal dominance rule, in this case, then only we what's the term? Generate the equation of the unknown. Generate equation of x1, x2, x3. Okay, this one I explain in general first. Later we go for the detailed explanation. Okay, now to understand the concept of the diagonal dominant first. Okay, these are the diagonal dominance rule. Anyone need me to repeat? Clear? Repeat. Okay, I go again. Diagonal dominance rule, where we need to find out from the equation. I use, I straight away use the exercise, the new slide. This one works for Jacobi and Gauss Seidels only. Jacobi and Gauss Seidel. Okay, I give new equation, new example, where let's say we have 5. Okay, let's say we have this. Wait, sorry. I use the one that need to rearrange, then you can understand. Sorry. Okay. Okay, so now the diagonal dominance rule. We take diagonally this part. Okay, this is A. I use A, B, C, easier. D, E, F. A refers to the number. Okay, step 1. Check the diagonal dominant. Where A over here is 3. Must be larger than 7 plus 13. Okay, let's see. 7 plus 13. You will get 20. So here it is smaller to the B plus C. Does it meet the rules? No, right? Okay, so equation 1, it doesn't meet the rules. How about equation 2, where E, which is the 5, must be larger than D 1 plus 3. 1 plus 3 goes to 4. And this is larger. So this equation meets the rule. Then check the third equation, which is also I, which is also 5, must be larger than 12 plus 3, 15. But here 5 is smaller than 15. So it doesn't meet the rules. For those doesn't meet the rules, you need to rearrange the equation. Okay, perhaps reposition the equation. Okay, so step 2. Okay, which go to which? Of course, move, replace each other, right? Okay, so the rearranged equation, the new equation would be, you need to rearrange first, then only we can generate the unknown equation. Okay, just to counter check the diagonal dominant. So you check back. A for equation 1 here, larger than 3 plus 5. Confirm. Correct. E larger than 1 plus 3. Correct. 13 over here, which is the I, larger than 3 plus 7. Correct. Okay, so now you can proceed to generating the unknown equation. Okay, from equation 1, the one that you have rearranged must be addressed to x1. Okay, so from equation 1 must address to x1. So from here, you rearrange, you will get equation 2 specifically for x2. Okay, so from here, you rearrange, you'll get the new equation for x1, x2, and x3. Okay, then equation 3 for x3. Don't mix up, huh? Because if you mix up, your answer will be different. Okay. Up to there. Okay, Ruben? Now, if your original equation already fulfill the diagonal dominant, so step 2 can be skipped. Okay, if the equation already fulfill the step 1, all equation fulfill the diagonal dominant, then proceed to step 3, generate the axis equation. Okay, in your answer in assessment, you must show this step 1 because you want to prove whether the equations is fulfilling the rules or not. I have previous student, they skip step 1. Straight away, they rearrange the equation. So they lost some mark on step 1 over here. Here, step 1 also brings mark. You must prove whether it meets the rules or not. Okay, up to that. Can that's me, okay? Now we proceed to the example. Okay, using this example similar equation as in Gauss elimination last time. So later you can compare your answer with the matrix answer. Now, for example, we have these 3 equations. Find the y's, y1, y2, and y3 using Jacobi and Gauss Seidel. Okay, along the way, I will explain what is Jacobi and Gauss Seidel. First step here, you must check the diagonal dominance first, whether it meets or not. Remember A, B, the arrangement, A, B, C, D, E, F, G, H, I. Up to you if you want to use this letter or the A11, A22, up to you. As long as you can prove the diagonal dominance rule. Okay, try to check whether this equation already fulfill the rule or not. Fulfill all the rules. Three equations, right? Okay. So we can skip the step 2, the rearrangement. Now proceed to the next step where you need to generate the unknowns equation. Okay, so y1 from equation 1. You will get this equation. Please be alert on the sign, positive, negative, minus, plus, because if you get it wrong, the rest of your iteration will be wrong. Okay, up to here, your y1, y2, and y3. Get it right? Yeah, I copy back the y equation here to the next slide. Okay, we need to move to next slide for the iteration part. Yeah, up to there. Okay, follow me closely, because I want to explain both methods together. So next step, step 3, iteration. Start with 0, iteration 0. Because later on, we start with 0. Iteration 3. Okay, remember the question just now, it asks you to iterate until 4 iteration. Then it asks you to find out the EA. So EA here is from iteration 3 and 4. Oh yeah, iteration 2, sorry. It's smaller. Okay, now we start with 0. Y1, Y2, Y3. First iteration, 0th iteration, starting point. Now to find this one using Jacobi method, I explained the Jacobi method. Now Jacobi method, it says values from the previous value directly used to the next iteration, meaning that for first iteration, your Y to calculate Y1, you use this Y2 and Y3, 0. Get it? To calculate Y1, you need Y2 and Y3, right? So this Y2 and Y3 coming from the 0 value. Okay, now by putting Y2, Y3 equals to 0, find out what is your Y1. Y1. 2.4, correct. Okay, so to find Y2, Y1 over here, using 0 as well. Y3, use 0. Okay, in Jacobi, each iteration using the previous iteration value. Y2, so Y1 equals to 0, Y3 equals to 0. You get your Y2. Negative 3.125. Similar to Y3, Y1 and Y2 equals to 0. What you get for Y3? 1.5, correct. Okay, so this is the first iteration value. For second iteration, Y1, so Y2 and Y3 over here using the value from the first iteration. Meaning that Y1, Y2, you have this 3.1, negative 3.125 and 1.5. use that value to get y1 in second iteration. Do you get 1.175? Right. Okay. So proceed until iteration 4. Okay, let's check whether you get the same value as mine or not. Okay, let me repeat. To get iteration 1, use values from the previous iteration column. 0, 0, you get y1. Okay, this one, use 0 and 0 as well. All from the first column, the previous column. Okay. Now to get iteration number 2, for y1, you should use y2 and y3 from the iteration 1 value. Then to get y2 from the previous column, okay, previous column. So y1, 2.4 over here, and y3, 1.5. Okay, Jacobi, it used the previous column, values from previous column. To get y3, so you need to use y2 and y1 from the previous column. Okay. Now what you get for EA? Y1. EA over here between iteration 3 and iteration 4. Because we use the most current values, which is iteration 4. Seven. All values here correct. Do you get this value or you get 7 point something? 013, right? Sabat, try to check back your calculation. Y2, you should be getting this. Then Y3, 4. 006. Okay, for Jacobi, Ruben? Now this is for Gauss Seidel. Still using the equation of y1, y2, and y3. And use the same column. Okay, so first column always start with 0. Zero's iteration. We haven't started anything yet, so start with 0. Then for y1, for first iteration in Gauss Seidel, y1, in Gauss Seidel, we use the latest value of the iteration. Okay, so y1 over here, the latest value of y2 and y3. Okay, so here the latest value is 0. Used to find y1. You'll get the same as 2.4. Okay, now to find y2, we need y1 and y3, right? Okay, in Gauss Seidel, it used the latest value. So y2, you use this y1, not the 0. You use the latest value of the iteration. So you use 2.4, then y3 is, the latest one here is 0. You will get your y2. Do you get negative 4.025? Right, negative 4.025, y2. Okay, then for y3, similar approach. You find the latest value. To calculate y3, we need y1 and y2. So the latest value of y1 and y2, which is 2.4 and the negative 4. Then using this value, calculate y3. What you get? 1.9603. Okay, Jacobi, it used the previous column. Gauss Seidel, it used the latest value. Okay, now to find y1 in iteration number 2. So you need to use the y2 from iteration 1, y3 from iteration 1. Then you will get your y1 for I2. I'll share with you the values. Let's check whether you get the correct as mine. This one to negative 2.99, not 97. Okay, get the same, Aisha? Okay, Okay, so now for the Jacobi and Gauss-Seidel iteration, first thing you need to check the diagonal dominance. If not meeting, you need to rearrange the equation. Then proceed with generating the unknowns equation. Then only you proceed with the iteration, either Jacobi or Gauss-Seidel, depending to the question. Okay, what I want to highlight over here, the question just now mentioned up to iteration number 4, right? Number 4. Make sure you start with iteration 0 because you will need to start from 0. So the labeling should be correct, I0. Because here, nothing happened yet, no iteration yet. That's why I0. If you start I1 over here, you will stop your iteration at the actual I3. So your answer is not finished. Okay, make sure the labeling is correct as well. Jacobi used the previous value from the previous column. Gauss-Seidel used the latest value of iteration. Okay, make sure you know the difference. From Jacobi and Gauss-Seidel results, what can you conclude? Which one is more towards the true value? Still remember the true value? What are the true value last time? From the matrix. From the matrix, the true value. The true value, the one that you calculate with calculator. True value is two. Wait, Itu. I read it properly. This one from the previous Gauss elimination example. We calculate using calculator to find the true value, to validate the answer. Okay, so from Jacobi and Gauss-Seidel values, what can you conclude? Which method is closer to the true value? Huh? Jacobi, Gauss-Seidel. Okay, so from here, you can conclude Gauss-Seidel is much more closer to the true value, approaching to the true value, compared to Jacobi. Okay, Jacobi Y1 0.9, where the true value is 1. Okay, this one we compare at iteration number 4 only. Gauss-Seidel values more closer to the true value. Okay, because Gauss-Seidel using the latest value. Okay. Any question? Clear? Actually, I have exercise. It depends. Sometimes it gives you up to what iteration, or else the ES, the stopping criterion. Let's say for this one, it said until 4 iteration, right? Then you need to calculate the EA. Okay, the question also can ask you to do the iteration until ES equals to 0.05, for example. So if ES equals to 0.05, then you need to proceed until you get your EA lesser than ES. The stopping criterion is either the error or the number of iteration. Get it nak, Tasmin? Okay. Actually, I have prepared few questions, but we are running out of time. We shall proceed tomorrow. Right. Okay, before we stop, actually, I want to discuss with you on the Friday class. Our midterm will be on this Friday, 11, right? So every Friday, 11, you don't have any class, is it? Can we move our 4 class to 11 a.m.? Can agree? Okay, so we will stick to that schedule starting next week. Sorry. Next Friday, no class. 29, no class. Because we had done with the midterm. So starting 6th of October, our Friday class will be at 11 a.m. You have class? You have class? What class? Physics? Only you? I have a few more suggestions actually. I put in CL, then you vote which session that all of you are free, so that we can move the 4 p.m. Friday class to that session. Okay? Okay, that's all. Thank you.